Dr. Jyotsna, that she has organized this workshop for you, because we learn so much from the people who come from outside. You learn from their experience, their expertise, both. And in the college, I know that teachers are expert and they are teaching you so many things. But when you get exposure of the outside world, it's really make difference in your life and your career also. So I congratulate the department, economics department, to organize such a workshop. And last but not the least, I congratulate and welcome the student of economics department who are actually will enjoy and get something from this workshop, because you will be the you are the stakeholders who are going to learn so much from this workshop. And I really hope that you will really try to learn everything from the resource persons. And when you will complete this workshop, you will be enriched person with the knowledge and new things which they will tell you. So thank you very much. I give you my best wishes for the success of this workshop. Thank you very much.
Thank you so much, ma'am, for these wise words. Now, I would like to request Kitty, ma'am, to give us a brief introduction about the speaker.
Good morning, everyone present here. I welcome you all to the workshop. Beginning again. Good morning, everyone present here. I welcome you all to the workshop on tools in data analytics and our software. I take this opportunity to welcome our esteemed guest, Dr. Santosh Kumar, Associate Professor in Department of Economics, School of Business Studies, Sharda University, Uttar Pradesh. Sir has completed his MA from BHU, Varanasi, UK, and MPhil from Central University of Haryana, PhD from Jawaharlal Nehru University, New Delhi. His area of interest are industrial economics, labor economics, development economics, and econometrics. He is proficient in econometric packages like Excel, Stata, R, CS Pro, unit level data, cross-sectional time series analysis, and panel data analysis is what interests Dr. Kumar. Many of his research work is published in various journals. We are honored to have you, sir. Therefore, without further delay, I would like to call upon Dr. Kumar, sir, to enlighten us with knowledge on data envelope analysis using our studio.
Okay, well, so a very good morning. So in this session, we will try to cover some applications and some models related to data development analysis. And a very brief introduction, but I don't think that it's a need to come here and brief introduction about our studio and knowing that. So here I'll be trying to complete 7 hours lecture within given time. So I need your best cooperation, and wherever you take some questions, some issues, just hold down in the end of session, that might be automatically solved. Otherwise, in the end, I will discuss it. Okay. So in this session, first I would like to introduce efficiency. Just open that. So data development analysis. This is a very important tool. I mean, statistical package. It's being widely used by the research scholars, practitioners, and specialists to estimate their efficiency. Because we always told that just do whatever you are doing efficiently. So are you getting me? The last? Are you getting me properly? But I'm not used to this use of mic. Okay, well, so I was telling that we will be discussing about the data development analysis, which enables us to estimate efficiency. If you want to measure the efficiency of this SPM university, another university, and we want to see that whether we are lagging behind or going ahead. So this is the use of data development analysis, I mean efficiency. So we will be estimating efficiency using R Studio, and you are well acquainted, I think, that with R Studio. So I'll be not discussing about that. So efficiency, but so okay, I'm not comfortable with that. So efficiency, that's nothing, but we are knowing that efficiency is just productivity. Means we may say that efficiency is the weighted output divided by weighted inputs. If we are based on, if this is based on, then we can say that this is efficient unit. So here we will be trying to estimate the efficiency of DMOs. DMOs may be decision making unit, maybe anything, maybe industry, maybe university, maybe bank, anything that makes decision. So it's nothing but it's a productivity. So आप शायद you have already studied about. Productivity. But then you are, I think that everyone is equated with what you mean by productivity. That's nothing but weighted output divided by weighted input. How much output we are producing per unit input. That's the productivity. And using that, we can say that whether it is efficient or not. But there is quite difference between efficiency and productivity. Productivity is an absolute term. It's an absolute term. But efficiency is not absolute term, it's a relative term. We can say that he is more efficient as compared to that person. Yeah, this university, I mean this college is more efficient as compared to other colleges. So it's a relative term. I told that this is a weighted output. Output is Y and input is X. I is number of that inputs. Number of I indicates number of inputs and outputs. And beta is nothing but it's a weight. And this gamma, that's also weight. So we are using weight because there may be more than one output and more than one inputs. Two inputs are more than two inputs, two outputs are more than two outputs. In that case, we use weight to combine that to estimate one value. So productivity is this. But whenever we talk about efficiency, that's a relative concept. We are trying to figure out that which one is best. Let's say for example, is it visible?
Yes.
Let's assume some demos like this university, this college, SPF, some other college, the Hindu, I'm writing here H only. The Hindu and Venkateswar College, Ramjas College, that's it. Let's say we want to estimate the efficiency of these colleges, and then we need output and inputs. Let's say number of enrollment, number of students enrollment. Enrollment number, I mean number of students who are enrolled here. That is, let's say, that's enrollment number in thousand. Let's say 1,000, 1,000, 1,000. For simplicity, I am taking only one. Let's say number of teachers. Okay. Number of teachers, that's let's say 300, 400, 200, 700, 800. Number of rooms. Let's say 30. 300. Let's say 200, 400, 300. Let's say 500. SPM college is also very big. So let's assume here 600 rooms. So suppose that these are the inputs on the basis of which enrollment number of the student can vary. So these are the determinants of enrollment. Enrollment of the students can be determined and be explained with the help of number of faculties available there and rooms, space. So we have to measure enrollment number per teacher or faculty. This is the number of teachers per teacher and enrollment number of students per rooms. Since we have taken one, that's why it's easy to measure there. That will be 4, 2, 7, 8, and 6, 4, 3, 5. A teacher out of that's a teacher out of number. You can take the for simplification I'm taking it. Otherwise you can take that's also. But we should always take output divided by input. Okay, just take 1 divided. Okay. That may be 10 out of 4, 10 out of 2 because it's 100 and that's 1000.
Yes.
We have to be very clear with our zoning. That's fine. Can we roll up? Please, I need more space. I need space. So which one is better? That's why we have to change the plotting it on the diagram. This is enrollment number per teacher and enrollment number per classroom. Maximum is 8. Just consider these numbers as a 1 byte. Not 1 byte, that's a 10 byte. So first plot these when enrollment number per teacher is 4, then total number of enrollment number per row is 6. Next year. That's SPM. Yeah, considering these number 1 byte. And for
Start with 1 by 8, 1 by
we can start. We can start. These are 1 byte. 1 by 2, 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8. Otherwise, you can divide it by also suppose that this is 10 out of 4 because we have considered it in 1000 and these are 100. So 10 out of 4 that may be something 25. So
1 by 8 would be
that's why that's why I'm not using that 1 byte. For simplification, I am taking it. Just we want to figure out that how can we estimate efficiency. Efficiency is 4 byte.
all units in the same enrollment number of each different grades. So that it will become easier.
That will be easy, but in this way you can also understand the behind it. Okay, well. So don't just consider here 1 by number, so that we can map it. But when we will considering 1 by, then that highest number will be lowest. So I am not writing here. It's very simple fundamental. You can understand this. Okay, well, let's plot second. Where enrollment number per row is 1 out of 4. I will go. Then enrollment per number teacher is 2. This one. This is the Hindu college. And another one is 3 and 7. 7. 7 and 3 is not.
7 and 8. 7 on the x-axis.
Requirement for teacher is
7.
7. That's 3. This is Westchester College and
8 by 5.
8
And 5.
this.
With the loop.
That's Ramjas College. So, to estimate that which one is more efficient, see here, where is highest number of enrollment per teacher? That is this. So H into is efficient as in terms of enrollment number per faculty. But what about enrollment number per row? Lancaster is more efficient. So this the Hindu. Just hold your question. Please, I requested you in starting, hold your question in the end of session. That may be automatically sorted out. I'll be explaining that. So this is Hindu College and this is Lancaster College. So let's join it. So this is only we found that two colleges, Hindu and Lancaster, are efficient, but this SPM and Ramjas College are inefficient. Why? Because these colleges, both colleges are not falling on frontier line. This is efficient frontier line that can also be said as a production frontier line. But we are saying here that efficient frontier line. It's efficient frontier curve. And according to efficient frontier curve, this is convex, not concave. Why? Because we are trying to estimate the output according to their inputs. According to their inputs. That's why it's a convex. But in case of, adjustment in the output using same level of input, where we keep input same, then it will be concave. So these are these are nothing but output divided by input. But now if we say it is not that, that is productivity. According to their productivity, we have plotted these colleges on this frontier. Now we found that this Hindu college is most efficient and Lancaster college. These are efficient. And these group of efficient DMOs, these are DMOs. Earlier I was explaining that those units which can make decisions like industry, like college, like banking, and institutions, those are DMOs, decision making units. So Hindu and Lancaster college both are efficient. And group of efficient DMOs are known as a peer group of industry, peer group of DMOs. According to those group, peer group of DMOs, those DMOs which are not efficient, they should to follow them. They should to adopt their practices according to their own existing practices. So when we found here that SPM and RJ are not efficient, when we draw the straight line, So what we have to do to make these, if it's I mean SPM and branches college coefficient, we have to pull them. We have to pull them to this frontier so that they can also follow up this frontier. So to pulling them because these are inefficient. These are inefficient, that's why we are pulling them to make them efficient. So how much we have to pull? Suppose that we have to bring SPM from A to A dash, this point, and branches from B to B dash. Yes. When we bring branches from B to B dash, that will become efficient and that will be SPM. So let's say this distance is B1 and this distance is, let's say this is B A dash and B this distance. Is there any other color? Okay, well. So I'm removing these lines. So now we are clear that SPM is not efficient. To make SPM efficient, we have to pull that to A dash at this distance. Suppose that this is DA dash, and this total distance is known as EA. Then what will be efficiency? Efficiency that will be efficiency is equal to DA dash divided by DA. So ratio of that, if is same DMOs and that DMOs. That is, if we say DMOs, this A dash DMOs, let's say virtual DMO. If virtual distance of virtual DMO from the origin point and distance of actual DMO is called efficiency. So this score we will be estimating. So how much is inefficient? This distance, I mean DA minus DA dash. This is. So this much we have to make change to make it efficient. So what is inefficiency score? That is A to A dash. So this is nothing but this is technical efficiency, technical inefficiency. That we have to remove by improving our practices or using more technologies. So efficiency, we are trying to improve efficiency of the existing technologies or adopting some advanced technology. Well, so this we will be estimating so we have to not do that much work, but we have to just do some linear programming. So to estimate that efficiency score, there are two most widely used models, that is stochastic frontier model and data envelopment analysis. Stochastic frontier model, that's a parametric test. However, DA model is non-parametric test. So stochastic frontier model just decomposes error term into usual white noise and efficiency, which can be handled out. Okay, well, so but here we will be studying only about data envelopment analysis to estimate that efficiency score and how to interpret it. Data development analysis, why we will be using here, why I'm suggesting to use in India case, because data are heterogeneously distributed. I mean, data is heterogeneously distributed across the country, and this model is free from distribution assumption. There is no need to follow that normal distribution assumption of the data, I mean variable. That's why mostly we use this data development analysis. Many advanced techniques are being used nowadays, but this is most prominent as well as that SPS. I mean, stochastic frontier model. Accept. So I told that efficiency is very important to explain total factor productivity. Because nowadays we use more than 2 inputs like capital, labor, raw material, energy, and so on. That's why most of the DMOs are producing more than 2 output: byproduct, main product, primary product, byproduct, and so on. So, but we have to be very careful that number of observations, I mean, let's say sample size must be equal to or more than 3 times of sum of number of inputs and output. We have to follow that. So once I said that, we can say how can we make those SPM and calculation functions into and calculation more efficient and SPM and Ramjas. How can we make efficient them? Either reducing the inputs to maintain the same level of enrollment number. Let's say in industrial crowd, to produce same level of unit, how much inputs can be reduced? In this way, we can make industry efficient. Either using same level of inputs, how much more output can be produced. So we will be trying to minimize inputs in some approach, in one approach, in another approach, we will be trying to maximize output. So when we try to maximize output with the same level of input, that is known as a output oriented approach to estimate efficiency. And in input oriented method, we try to produce same level of output using less level of input. That is known as an input oriented method. So there is 2 types of approach to estimate that. See, same thing we have studied here, that this is output oriented method where we are trying to maximize output. We are pulling the frontier model. And in that case, in input oriented model, that is input oriented model where we are trying to pull the frontier curve. So see, the DMOs A, K, B, K star, and C. These are efficient because these are falling on frontier model, that is production possibility curve, and that is isopoint curve because we are trying to plot that same level of inputs. I mean, combinations of output inputs that can produce same level of output. So in that case, A, B, K, C, D are efficient, and X, Y, Z are inefficient. Here M and N are inefficient. So how can we estimate efficiency score here? O K star divided by O N. And how can we estimate their efficiency score? O K star divided by O Y. So one thing notice here. In case of output oriented method, the efficiency is 4. This divided by this much. That is more than 1. But in case of input oriented method, efficiency score will be less than 1. So whenever you go through anywhere from efficiency score by value, you can figure out that you can identify that whether it is input oriented method or output oriented method. When efficiency score are more than, efficiency score is more than 1, efficient. If more than one, that's not efficient, that's inefficient. So see here, we dividing here and we found that 0.80 value of efficiency score. When we divide, that's input oriented method, no? Because it's less than 0. Less than 1. Let's say our value is so what is efficiency now? Efficiency is distance of best PMOs. Efficient. Actual divided by base PMO. Yes. That was DA dash divided by D. So suppose that we find value 0.80. That's less than 1. So it indicates that this is input oriented efficiency score. So what is inefficiency level? To find out, this is efficiency score. To find out inefficiency score, inefficiency level, we have to subtract from 1. So that's around 20%. That's an inefficiency level. So in case of this PMO, there is 20% level of inefficiency. So we may say that input, remember that input can be to produce same level of output, yeah, same level of output can be produced by using 20% less level of inputs. So we can suggest that there is technical inefficiency is 20%, so we can reduce our input 20%. Okay, so I stated that there are two basic models as here, that is stochastic analysis of analysis, and there is data envelopment analysis we will be using because it is free from the distribution. These are the examples that we have taken two output y1 and y2 and three inputs x1 and x1, x2, x3. This is just example. But what is mistake here? PMOs are, we have 5 PMOs. Can you identify what is mistake here? Why? Because number of demos must be more than 3 times of inputs and output, and here are only 5. So remember it. So I stressed that we will be using two approaches to estimate efficiency score, that is output analysis, but I will say in class. So there will be two approaches to make those inefficient PMOs to efficient. There are two approaches. First is output oriented approach and input oriented approach. In output oriented approach, we try to maximize our output, which can be produced with the help of given inputs. So suppose that we have output m is just number of demos and I is number of demos and m is number of output. So suppose that m is 1 and 2 output we have, and here lambda I and x and I, that is input. Lambda is nothing but lambda is very important. It's a weight, and weight, that envelopment analysis. Sorry, I didn't explain that why do we call it envelopment analysis. In that now, see in this graph we are trying to envelop all the DMOs with the help of peer group of DMOs. And there also. That's why we are trying to envelop all the DMOs. That's why this is known as the data envelopment analysis. Okay, well, so this model was given by Charles, Cooper and Rod in 1978. After 6 years, again this model was developed and given by Banker, Charles and Cooper. So in that case, they estimated efficiency score using CRS assumption. CRS is nothing but constant returns to scale, and I think that we are implemented that. Huh? And here BCC, that's a Banker, Chance and Cooper. They developed that model because that was based on constant returns to scale, which is not in actual. That's why they have included it, and then they have developed it and make it variable returns to scale in after 6 years. Where we also try to maximize output with the given inputs, but 1, 2 may be include variable returns to scale. We include one more subject, sub constant, that is sum of lambda is equal to 1. When there is lambda is equal to 1, then we can say that this demo is follow the variable returns to scale. It's not operating at constant returns to scale. It may be operating at decreasing returns to scale, may be operating at increasing returns to scale. So one constant we have to add here. So next, input-oriented model, we try to minimize that inputs by adjusting the weights which are assigned to the inputs. So we are trying to here manage the weights only, so that we can minimize it and maximize it. So here we are trying to minimizing the inputs with the adjustment in the weights. And here also, but that is based on constant returns to scale, that is CCR model, and BCC model, that is based on variable returns to scale. So these are the examples. So see, we are trying to assign here, this is output oriented model, and we are trying to maximize this theta, so that output can be maximized, but using same level of inputs. Some of these inputs are same, but we are trying to here maximize output. So these are the numbers which can. Actually, these are the linear programming method. This is BCC model, output-oriented approach, and both are the same, but one more constant is here, that is sum of data is equal to 1, and here that constant is not included in that. So that's a BCC model. Okay, this is scale efficiency. So in this way, we estimate CCR efficiency score, that is constant returns to that is based on constant returns to scale, and BCC, that is based on variable returns to scale. So, and one more thing, that is as C, that is scale efficiency. By dividing that CCR efficiency score by BCC efficiency score, we estimate scale efficiency, so that we can suggest that whether they should to expand their scale or they should to utilize their existing inputs. So those weights, sum of weight, I explained earlier that when it is not constant returns to scale, when it is based on BCC model, then if there is sum of lambda is equal to less than 1, that is decreasing returns to scale. When sum of lambda is more than 1, that is increasing returns to scale. When 1 is constant returns to scale. That's yes. Okay. So this is total vector productivity growth. So we estimate total vector productivity growth, but we don't estimate the. We can decompose this total vector productivity as the sources of the total factor productivity growth, whether that total factor productivity growth is due to technical change, I mean use of more advanced technology or use of more technology, either use of efficiency of existing technology. So we can decompose this total factor productivity growth into technical change and technical efficiency change. So there are also more efficiency score like pure efficiency, which is managerial efficiency, whether that is more efficient because of their managerial power, whether they are following they are practicing their base practice and are not. That can be explained with the help of pure efficiency score that can be estimated, but today I think that I'll be skipping that, but that's very easy. So here that we have decomposed using the Malmquist index. So okay, great. So now we will do the practice. Yes. Variable interest.
Yes, there was a constraint between some equation we want, but there's some
Don't follow that in some of words. See, that's a constraint. That constraint subject to given constraint. Constraints must be constraint that sum of lambda is equal to must be 1 in variable interest system. Here sum of value of sum of value of lambda. That is constraint is that's a constraint that's efficiency. Both will be different.
And variable may be not say that condition need not happen. But for constant terms, the other side that it has to be
That's what. See, wherever we estimate CCR model, we will be unable to figure out that industry, whether that industry is working or operating at increasing industrial scale or increasing industrial scale. So in that case, we don't use sum of lambdas to identify that. But in case of BCC, we use sum. That's why we are saying that in case of that sum of lambda must be 1. So I think that to have that software, to estimate that first we have to install some package because this is statistical software. RStudio is a statistical software, statistical packages. So to estimate data development analysis, we use some package. We have to install some package that is benchmarking. Okay, well. So this is RStudio. You might be well acquainted with it. That's a data section. That's your result and command section, and characteristics of variable. From package, to install packages, you can install from here. There is some tools. You have to go to tools. You have to search here. Their benchmarking. Nice. What did it? Yeah. हमने freeze कर दिया क्या? Press किया क्या? So whenever you so first it looks like This. So first we have to install benchmarking, and we can install benchmarking. Just go to tools, that is in menu bar tools, and install packages. Search here benchmarking. Okay. So go to this. There is plot. After plot, there is packages. Go to packages. Just search here benchmarking. Okay. Benchmarking that you have to install. It is already installed in my this software, my package. That's why it's so. Just go to here. There is package. See. Just go to packages here, and search benchmarking. Install that. After that, we have after that we have to activate some software. I mean some packages. But before that, just import the data. There is data section. Go to there. This data section, you can import the data from here, from any, if the data set is available in SPSS, SAS, Stata format, text format, any format. So we are importing data set from Excel sheet. So we have to browse wherever we have kept our data. You just learn. I'll be providing each and everything in the end of this session. So while we going through that, that will be quite helpful. So data that is already stored in that. So we have to import it. So data is this is. So this is data. Yes. So this data, there are 2 outputs and 3 inputs. So to perform this data development analysis, first we have to combine inputs together, and we have to combine all inputs together and all outputs together, so that there will be only 2 new variables that will be output. Well, let's say y, capital Y. There are capital Y and y1, y. Let's say small y and small x. So to combine that, but before that, what we have to do, we have to activate 3 packages. That is DA, LP solver, and UC, and these packages we have to install first. See, we have to already attach the data. So there are 3 packages: LP solver, UC, MINF, and another one is benchmarking. Every time, whenever we go to estimate efficiency score, every time we have to activate these packages. After activation of this mechanism, we can estimate that. So we can run it. These are already, see, whenever this is, I mean, the command will be red color, that's not working. It means that there is error. When it is green color, that's okay. Then we can proceed with the blue color. So now benchmarking is activated. So now we have to combine the output. Let's say we have attached trend data set. Okay. Well, now see, there is that command. We are combining data. That is our file name. We are combining here y1 and y2, which are output. And we are assigning here y is greater than dash. It means that we are combining y1 and y2 and storing into y. So whatever name you want to give, you can. There is no restriction to give that. But you have to know that it must be reflection of that it is output. So that's when we combine it. It is combined. To see it, we can give a command only y. Whatever we have stored, by giving that command, we can see that data. See now, y1 and y2 both are combined. Similarly, we have to combine inputs. Let's say combine inputs, and we are combining x1, x2, and x3. x1, x2, and x3, and assigning that capital X as an input variable name. So when we run, otherwise we can type here. I have written the script because I was trying to complete all the things which are 7 hours lecture. That's why I have already written it, but I'll be giving. So we can run it now. That inputs are also combined. Now, when we write only X, then we can see the input. Sorry. See now X1, X2, and X3 are combined. Yes, now we are able to estimate the efficiency score. So to estimate the efficiency score, we can search here DEA that's in benchmarking. See, if there is issue in command, then you can search the commands. What is command? Come here. Data environment analysis is a part of benchmarking because we just provide, we consider those JMOs which are efficient as a benchmark. That's why it comes under the benchmark. So by going there, we can estimate, we can identify the formula, exact formula. So see DA model, when you will click on this, it will show the, then it will show the formula. So then, see, this is the formula which we can use. But I have written there. See, this is formula.
Zoom in. थोड़ा सा
Okay, now it is visible.
From the back, is it visible now?
It is visible. Okay. Okay, well, so that what is that? That is, so we are estimating CCR model. I am writing here ECCR because the result we want to save in ECCR. E stands for efficiency. CCR model, that is Chance, Cooper and Rod. That is based on constant returns to scale. And we are estimating, that is storing. That less than is that shows that we are storing that. Whatever we are estimating using the DEA bracket within bracket X and Y. First we have to mention input, then we can mention output. Remember it. We should not mention first output then input. First we have to mention input. And RTC shows that returns to scale, and we are using here constant returns to scale because it is CCR model. And that is based on constant returns to scale assumption. And orientation is IM, which indicates that we are computing input, we are following input approach, input oriented approach. Where we write here ON, then output oriented approach will be OO, not ON. So when we give this command, it estimates efficiency score. That's CC efficiency score, CCR. Okay. That's estimated. So actually it is already stored. That's why it is showing red color. Otherwise it will be blue color. So we have 5 demos, 1, 2, 3, 4, 5 ABCD, in which A, B, C, D are efficient because their score is 1. But here another one is last one, that is E. E is not efficient because its score is less than 1, and it's an input oriented approach. That's why the all scores are 1 or less than 1, not 1 or more than 1. In case of output oriented approach, that will be more than 1. So when we subtract this 0.871 from 1, that will give 13% around. And this 13% is nothing but this is technical inefficiency. So we can say that same level of output can be produced by EDMOs, E-industry, by reducing with the help of 13% less input. So they can reduce their input. Now they have to work on that. How can they reduce? And so we can estimate lambda values. These are nothing but these are weights. So that weight we can check out that when weight is 1 per 1, that is constant returns to scale, but we should not follow, we should not identify the DMOs while following this. We have to follow that another one, that is BCC. But here we can identify that the lambda values is not 1 for this 5. When we add, it will be something, let's say 86 around. That's around to approximate that is efficiency score around 86, 87. That is less than 1. That's why we can say that demo 5 is working on decreasing returns to scale. But we should not say here. We can say in the case of PCC, and same result we will be finding in that case. So to estimate that BCC model, now we are estimating BCC model, and that is XY RT S is there is change, that is we are writing here BRS. There that time we were written there CRS, constant returns to scale, but here we are writing here variable returns to scale, and we are following same approach. Don't follow input approach in first CCR model and BCC approach output oriented model. No, we have to follow either output oriented model or input oriented model. So we are following here input oriented model. When we run it, it is already stored. So okay. This is my code. So first I am shifting in another data set because that's not working. But to shift here, first we have to attach the data set. So let's attach the data set. यहाँ से down. Okay, so these are efficiencies for fitness score. These are the lambda value. So in this we have some 10 industries. These are efficiency score, that is BCC score. That's a banker chance in cooper store, which is based on variable retention scale, and efficiency score are less than, which shows that we are following input oriented method. And suppose that this is 56.565, let's say 57, so there is around 43% in efficiency score. So we may say that in this, that we have to count how many. I mean, there are 20 industries right now. So let's say this is 17, 18. So we can say that 18th industry can produce same level of output with the 40%, 43% less level of input. And these are the Lagrange values. So here this is based on variable industry scale. So we can figure out that whether the industry is working on increasing, decreasing, or constant industry scale. We can figure out that by getting the sum of these Lagrange values. So that's a scale efficiency. This is scale efficiency. In case of input oriented method, if the value is more than 1, that's an exception case. That's an outlier. You have to drop that value. So this last number of industry, that maybe 20th industry, that is outlier. We should not include it in the diagram, because whenever we plot that frontier model, that will be different from it. That will be much away from the others. So these are output oriented method, because values are more than 1. See, we are estimating the data development analysis. These are inputs, these are outputs, and we are following variable returns to constant returns to scale CCR model. But by following output approach, so efficiency scores are coming more than 1. So see, in this case, it was around 46%. So we may say that, sorry, In this case, we have to drop it because this is more than 2. It must be 1 to 2, let's say, because 100% we can't double that. That's why these are the outliers. We have to drop this variable from our main data set. So in other case, that is between 1 and 2, that's okay. So when we subtract from 1, we will be getting some number. Let's say this number, that is 75. So we may say that our output can be more, that we can produce 75% more output using same level of inputs. And here 28%. So in this way, we can interpret the efficiency score and we can suggest the practitioners and industries to follow that. These are same lambda values by summing up So now we are estimating BCC model. That's a banker chance Cooper model. That's an output oriented model. So all the efficiency score must be more than 1. So we are getting here. So see, this was I think this was outlier, but here in the output oriented method it's coming under. So by following both approach, we can figure out that which one is more appropriate, so that we can follow that. Otherwise, on the basis of our methodology, whether there is chance to decrease in inputs or there is no chance to increase in output, on the basis of that we choose the orientation. So that's output oriented method. Here, by summing up it, we can identify that whether that number of industry, let's say, as number of industry is working on operating on decreasing returns to scale or increasing returns to scale or constant returns to scale. So, scale efficiency, that's the main thing which we were trying to find out, that ratio between CCR model and BCC model. That's a scale efficiency score. So that's this one. We are storing here that scale efficiency score in case of output orientation is CCR model, I mean efficiency score by following output oriented method which is based on CCR model divided by this BCC model, variable interest scale. So that is scale efficiency, so that we can suggest whether scale can be expanded or not. So we are finding here this is scale efficiency score divided by that. Okay, so whenever we give this command, this will not come. To see it, whatever we have saved it, we have stored, wherever we have stored, we have to give that command so that we can get these values. So these values come. When we give this number SCOO, that it will appear in our result will appear. So in this way, we estimate CCR efficiency score, BCC efficiency score, lambda's value, and scale efficiency score. And plot we can. This is that frontier plot. Using this frontier plot, we can figure out that whether industry is operating on frontier or not. So here we are seeing that number 3, number 10, number 7, number 4, number 8, these are operating at frontier model. I mean frontier car. 3, 10, 7, 8, 4, there are more numbers. So these are operating at frontier. So we may say that these are the group of PS group. And these which are operating under this frontier, those are not efficient, these are inefficient industries. So they should to follow practices of those peer groups. I mean, they should to follow their practicing, I mean management, I mean wherever they are heading them, they should to follow these peer groups of the industry so that they can also improve their efficiency level. So we can plot this efficiency score by dividing it. We can figure out the same value. When we divide it this from OG to, let's say, this is some number, that is fifth number, 15th industry. That's 15th industry. We can figure out the estimate. We can estimate the efficiency score for this industry, number of 15 industry. When we draw a straight line, which goes here. So this divided by this, it means it's a concave. Why? Because we have follow output oriented method. Oh. When we follow the input oriented method, that must be convex. So we are trying to pushing. So by pushing this industry, we may push to them so that they can also achieve the frontier. So this is what about I was supposed to know. I think that I am in the time because I have discussed many things.
Okay, anyone have questions to ask? कोई क्वेश्चन है तो
Okay, now do you have any question? Okay, well. Okay, well, so I'm just going to explain the PPT so that you can figure out the commands which are given in the PPT.
मेरे को देखो
This page, everyone knows. Everyone is familiar with this page. So this is to install benchmarking from here. You can install from here. And after installing that, we need to activate 3 packages: LP, solver, and some was UMI and CM, and benchmark. Every time, each and every time, whenever we estimate that, we have to estimate these packages. After you can activate before the importing the data, then you can import after that also. Then after importation the data, we should to combine, we should actually categorize entire data set into 2 categories: inputs and output. And then we can estimate by giving the command DEA within bracket inputs, outputs, then orientation, that is your constant variable returns to scale. BRT is equal to, when we write variable returns to scale, that will be BCC model. When we write CRS, constant returns to scale, that will be CCR model. Then orientation comma. Within inverted comma, we can write here IN for input orientation, OO for output orientation. Then write when we give returns, then it will give the return. Then to see it, we have to store somewhere this. So what we write, wherever we want to store, we write some name so that easily we can identify. So suppose that if we want to estimate efficiency score based on BCC model, which follow the BCC efficiency score based on input orientation model, then we should write some, let's say BCC, so that this BCC efficiency score OO, output oriented. Whenever we hit it, then it will get our result. Acha, one more thing I forgot to tell you. We can export the data from here to direct Excel. And I also show that results. Okay, so we have imported the data here. These are the in PPT, and PPT will be provided to you. So we are activating those. I mean, let's say we have this. So here we have attached the data. First command, then we have to activate those packages, the packages. Then we have to combine the data, output and input. Then we can estimate, computing the CCR efficiency score by following this formula command, and BCC score by following this formula, and scale efficiency by following that command, and print. We can print like this. Whenever we give the command this, then it will give the chart. So result, whatever we want to figure out, we want to in our table, we can write here, and we are trying to say here, just mention number demos, I mean name of demos 1, 2, 3, 4, 5, 6, 7, 2, 15, 20, whatever demos we have. Let's say 5 demos, ABCD here, 3, and then efficiency score, and that is constant frequency scale, and efficiency score based on VRS frequency scale, मतलब CCR model and BCC model, then scale efficiency, then lambdas, and variable frequency scale lambdas. मतलब by following this, we can figure out that whether it is operating at decreasing or not. I mean increasing frequency scale. So whenever we give this command, then we have to write again to see the command, to see the result. We should write results only. Whenever we hit the enter we say that return. Whenever we hit the return, then it will give the table. So that table we can export into Excel format by following this command. And these are given in that packages where I shown that from there we can identify what is the exact command. So whenever you hit this, you will be typing. I'm writing here desktop sound text folder. In that folder, that result will be printed. So this is nothing but this is path. This is path wherever you want to keep your data. I mean wherever you want to export your results, you have to use the path. Then these codes will have to be sent. And these commands are given also in this way. These three. Thank you. Important thing. RBI routine is inviting the research paper based on this. We can estimate the India efficiency as compared to other countries, but we have to identify the output like GDP, reduction in death rate, increase in life expectancy. These are outputs. Inputs might be opening up, that's expenditure of government or health sector, energy sector, number of hospitals and this banking sectors. So many.
so much, sir. Thank you so much, sir, for an amazing section. And yeah, I'm sure we all have gotten an idea about what he was trying to explain. I would like you all to please give him a big round of applause. I would like to request Manisha ma'am to come forward and explain the role of her.
I extend a warm heartfelt thanks to sir for coming here and being with us. He has given us a new introduction to BE analysis, where we are talking about output-oriented approach and input-oriented approach. Hope you have learned everything very well. But if you haven't, then please go back and run those commands and it will be very clear to you. First, I'd like to thank our principal ma'am, Mata Sharma, for the constant support. Then I'd like to thank our convener ma'am, Dr. Gupta, all the co-conveners that are here, all who have done the work in the background. And then I'd like to thank all the faculty members, non-teaching staff, and the students of the conference who have made this event a smooth flow this year. So, thank you everyone.
It's my pleasure to be here. And actually, I tried to complete most of the things, so maybe not that much informative. But I think that you have got some idea. But it needs at least seven lectures. Thank you.
Okay. Programming isn't about what you know, it's about what you can figure out. With this quote, I would like to end this session. Thank you so much, sir, for sparing your time and energy for this event. Today, it was a pleasure to have you with us. Once again, thank you each and everyone for this, for making this event a great success. Please a huge round of applause for all of you. I'd like all of you to please remain seated and sign the attendance sheet if you haven't. Also, the feedback form would be released at 7 p.m. today, and you have to screenshot the R's console, your R console on that, and therefore you'll get the PDF, get the certificate if all of you attend all the 3 days for the workshop. That's all. Thank you. And I would request all the coordinators to please remain seated. We need you for a little while more.